All right. Hello, everyone. Thank you for joining us. Hope you're having a great day, depending on your time zone. Welcome to Citrix Ready Technical Webinar Series. I am Sagnik Datta, and I'll be your host today, where we have Pure Storage and Cisco systems with us. The title of the topic of today's we're going to cover is on a very large scale XenDesktop 7.9 deployment on Flash Stack. And along with me, I have our main speakers, Mike Brennan, who is the Product and Technical Marketing Manager at Cisco Systems, and Kyle Grossmiller, who is the VDI Solutions Architect at Pure Storage. Moving on. Next slide, please. To introduce you to Citrix Ready is an end-to-end technology partner program. We help you make a better purchase decision when looking out for third-party products that work with Citrix. We showcase these on Citrix Ready Marketplace. Details you can browse onto the links shared below. And if you're a partner and willing to join us for as a Citrix Ready partner, please you can look into the next link, which is the citrixready.com partner program /Citrix Ready. I'll be handing over now to Kyle and Mike to introduce their companies. But before I do that, a couple of housekeeping items. For questions you have during the webinar, please type them down in the question panel available on the right-hand side, and we will respond to them while the webinar progresses, and also additionally take some more details on question and answer session at the end. All right, now, without further ado, I will roll over the dice to Mike. Mike, I welcome you to the Technical Webinar Series, and let me now hand it over to you.
Thank you, Sagnik. This is actually Kyle. I'm going to start briefly by introducing Pure Storage. So we were, as you can see on the screen, we were established in 2009. We shipped our first product in 2011, and we've been a Citrix partner since approximately middle of 2012. We've coincidentally also been partners with Cisco right around then as well. So thank you guys both for your partnership. We went public in October of 2015, so we've seen very robust, very exciting growth. And the main reason for that is that we are, our company is, or our product, excuse me, is purpose-built to use all flash from the ground up. Mike, I'll pass it over to you. Mike, I think you're on mute. There we go.
Oh, thanks, Kyle. Just having some slow reaction time on the controls here. So thanks, Sagnik and Kyle, both for the opportunity to work with Pure Storage and Citrix on this study. Cisco has been around for a while. We were established in 1984. We've been a Citrix partner since 2009 when we introduced Cisco UCS to the marketplace. And for those who don't know UCS, Cisco UCS back in 2009 really invented the idea of a software-defined data center with UCS. Our products, run XenDesktop and XenApp at higher user densities with really excellent end-user performance. And we feature in UCS software-defined network, compute, and storage. And the whole system is a policy-driven configuration of stateless compute and hyperconverged systems. So we have lots of opportunities to use software to define the data center. So today for the agenda, we're going to talk about a VDI flash stack solution. We'll talk about an overview, some solution details. We'll look at the storage performance of the Pure Flash Array M50 that we use in the testing. And then we'll look at some proofs of what we did, and then we'll take some Q&A at the end. We have a lot of stuff to cover, so we're going to go relatively quickly. So first, a flash stack overview. So some of the key benefits for flash stack for desktop virtualization are the simple, resilient architecture for deploying the desktop virtualization solution. We'll show you some things around that later. It's scalable, so we prove linear scalability and performance from single server testing that we'll talk about out to thousands of virtual desktops or XenApp sessions in clusters, and then we'll go all the way out to 5,000 seat scale. So it's a balanced system, meaning that we give you the right balance of compute, memory, and storage to be cost effective. And that's a key element for VDI, always has been. We need to be, we don't need to be over provisioned on any end. And converged solutions like FlashStack give us the ability to tune that really well. And then it has to be simple to provision. So UCS Manager using service profiles and some of the technology built into the Pure Storage flash arrays are really easy to use. It gives you the ability to provision lots of blades really quickly and have them available for hypervisor deployment and ultimately workload use. And then we provide you with a Cisco validated design, and that design takes all the risk of accelerating and lets you accelerate your deployment. So there's a Cisco validated design behind this presentation that's supported by Cisco TAC and Pure Storage's support organization. So if you deploy against our CVD, you'll be getting the world's best support from Cisco and Pure, as well as Citrix. I should mention that Citrix is a support partner. We take level 1 Citrix issues at our Cisco TAC along with Pure Storage, and we'll get you the answer. It's not a case where you're going to have different vendors pointing the finger at each other for a problem that you may be having. So that's kind of how we reduce the risk of you deploying this solution. So here's kind of what it looks like. It's built on Cisco UCS with Pure Storage, flash array, and we use Citrix XenDesktop and XenApp 7.9 in the solution. We use PBS to provision our RDS hosted session servers, our XenApp servers, and we use PBS and MCS-based provisioning for VDI virtual machines, pooled and persistent, respectively. And the total workload, again, is 5,000 seat workload. So here's what it looks like from a project level. So the first two blocks on the left there are RDS, or XenApp sessions. We plan the system to run 2,600 XenApp sessions running on Windows Server 2012 R2. And we actually ran a knowledge worker workload against RDS, which is a little bit strenuous. I mean, RDS, typically those applications are more along the lines of office workers or task workers, but we wanted to give you an apples-to-apples comparison for loading, so we used that knowledge worker workload. For VDI, we did 1,200 non-persistent Windows 10 desktop users with Office 2016. The non-persistent desktops is indicated or provisioned by PBS. Then we did 1,200 additional persistent Windows 10 users, again with Office 2016, and they were provisioned using Citrix machine creation services. And we give you a comparison of the non-persistent and persistent in terms of performance on the storage and the compute layers, as well as a look at login VSI in that range. And then we take all our single server and cluster testing and we put it all together and show a 5,000 user mixed use case that really came out with very, very good performance at a really reasonable cost per desktop. And for high availability, in the architecture and the design, there is no single points of failure anywhere. We have non-disruptive operations during failures. We can have blade failures in a cluster. We can have disk failures on the Pure Storage. We can even have controller failures on the Pure Storage, and we'll show you some of that so that you can be confident that we can hold this load up in the face of a failure, and that's really important. And then we have rapid recovery. So in the event of a blade failure, for example, we can put a new blade in, deploy the service profile, and have it back online in 20 minutes. That's as long as it takes to get it back online. And that's faster than anybody else in the business. So we give you the highest performance, most carefully vetted solution, I think, in the marketplace, and you'll see some of that. So just again, the big goal was 5,000 users. How do we do that? How do we start out and do that? We start out with single server testing, the blue block on the left. We use the UCS B200M4 server. For RDS, for example, running Windows Server 2012, or for the virtual desktops running Windows 10 64-bit operating system with Office 2016 64-bit. And what we do there is we determine the maximum recommended load that that blade can hold for the application that we're running. So that tells us how hard we can run the server in a failure scenario. Now, the solution doesn't run that hard, but we have to be able to, engineer in the ability to run hard, and in the case of a blade failure, for example. So after we do that, then we move on to cluster testing, and we say to ourselves, okay, at the cluster level for XenApp and XenDesktop in persistent and non-persistent modes, in the RDS server session mode, we build a cluster that builds in that N+1 server fault tolerance, and we evaluate performance there. So 50% of our load was in a single RDS cluster running XenApp. 25% was in non-persistent VDI and 25% in persistent VDI, and so we have cluster testing around both of those. Once we have good confidence in the cluster testing, we move on to scale testing, where we put it all together, and we run 5,000 users mixed workload, and those numbers there in that yellow box aren't correct. It should be 50 and 50 instead of 30 and 70% as I described above there. And so, and once we are confident there, then we go on to resiliency testing, and Kyle's going to talk a little bit about that, where he's going to do an actual Purity operating system upgrade while the load is running, and then he's going to do a controller failure while the load is running, and he'll show you some insight there. Key thing is, for Cisco validated designs, we don't cherry pick our tests. Each one of the levels of testing, we have to have 3 consecutive tests with 0 stuck sessions. In the case of single server testing, no more than 2 or 3 stuck sessions on our RDS and cluster testing, and then at the scale testing, no more than 10 stuck sessions during that time. And what a stuck session is, if you're not familiar with login VSI, the test starts, all the users log in, they all start to execute their workload, and we watch and make sure that the all but up to 10 in the case of 5,000 actually finish all the loops in the test. So a loop is about 14 minutes, and we make sure that every user gets through a single loop so that we aren't missing anything on the performance end. So I spent a lot of time on that slide, but I think that's it's worthwhile to have you understand the rigor that we go through in presenting this data to you. So this is what the hardware stack looks like. So it's Cisco UCS B-Series blades. We'll talk about this a little more. Cisco 6200 series fabric interconnects. Our Cisco MDS 9100 series 16 gig fiber channel SAN switch. Nexus 9300 series switches. The Pure Storage Flash Array M50 that we'll talk about. Our Cisco Nexus 1000V distributed virtual switch that helps guarantee quality of service through the workload to make sure that the VDI desktop user traffic gets the highest priority. We ran this study on VMware vSphere 6.0 Update 1A as the hypervisor, and again, Citrix XenApp and XenDesktop 7.9 and PBS 7.9 as well for all the workloads. So you can see we can house this entire 5,000 seat solution in a single 19-inch rack, and we still have some room to expand down at the bottom of the rack there below the M50. So let's take a real quick look at the UCS performance components. The 9372PX switch is a line rate layer 2 and 3 switch that provides up to 1.4 terabytes per second in bandwidth in a 1RU rack form factor. It has 48 ports fixed, and then it has 6 QSFP ports at the end that are 40 gigabytes for uplink to core switches, or they can be broken out into each port can be broken out to 4 10 gigabyte connections. The MDS 9148S is a 16 gigabit fiber channel switch. The Pure Flash Array M50 is a 16 gigabit fiber channel capable switch, or sorry, storage device as well. So that's how we matched up for maximum performance. And the 9148s give you flexibility for growth and virtualization, easy deployment and management, and it's optimized bandwidth utilization to reduce downtime. Enterprise class services on this switch. And then, of course, the MDS and the Nexus switches could be connected to multiple flash stacks that are in these 5,000 seat configurations. And then finally, the Cisco UCX 6248 UP. The UP stands for Unified Port. We can run 10 gig Ethernet, or we can run fiber channel, or fiber channel over Ethernet, or iSCSI. Any protocol can run on the fabric interconnects. This is the brains of the UCS system. It gives us the ability for 960 gigabits per second of backplane throughput. It's super high performance and flexible. It gives us the ability to give each one of the compute nodes behind it their personality. They're stateless when you take them out of the box, meaning no burned in UUIDs, no burned in MAC addresses. Nothing is static in this system. It's all provisioned by software, and therefore software-defined networking and storage and compute. And we can also create policy there for network adapters, VLAN configurations, quality of service, and storage components. So we can actually program uplinks to the MDS switch from the 6248 to give us connection to our fiber channel based flash array M50. And the final card on the bottom is our VIC 1340 MLOM. It's a 40 gigabit throughput. It has 4 10 gigabit channels. It is an MLOM card, motherboard on LAN card, LAN on motherboard, not motherboard on LAN. It gives us 4 10 gigabit lanes out from each blade into the chassis. There's a 1280, there's a 1380 version of this card that'll give us 8 lanes if we need more throughput. For VDI, 4 10 gigabit lanes per UCS B200M4 is plenty. So this is what a B200M4 server looks like. You can see that it goes into our 5108 blade chassis on the bottom. The blade chassis has 8 slots for these half-width blades. The half-width blades are 2-socket blades with 3 memory channels, 24 DIMMs in total. Using a 64 gigabyte DIMMs, we can actually do about 1.5 terabytes of memory on this each blade server. It's a dual socket. We used Intel E5 2680 V4 processors here, and we'll talk about that some more. The cool thing about the chassis is everything is fault tolerant. You can see that there are 8 hot swappable redundant fans, 4 hot swappable redundant power supplies, and in the middle of the chassis you can see a backplane card, and there's one over on the left side as well. Those are our I/O modules, and those are for communications from the chassis up to the fabric interconnects. If you need more information about how the servers work or what they look like, there's a URL on the slide here that you can click to get there. So with that, I'll turn it over for a little bit to Kyle to talk about the flash array M50.
Thank you very much, Mike. Very, very good stuff. So yeah, if we could advance to the next slide, I'll walk us through what our array looks like from a hardware perspective. So as I mentioned at the beginning, one of the differentiators for Pure Storage is that we truly designed our platform to be optimized for all flash from the ground up. So what we can see here is our Flash Array M base chassis. It's a 3U chassis. You can add 2U expansion shelves to it, but the base unit is this 3U chassis. In the front, which is on the left there, you can see there are bays for 20 solid-state drives. I believe in the current M50 release, we can go up to, what is it? I think it's something like 80 terabytes raw space just in this base 3U chassis, and that's not factoring in our data reduction capabilities, which for projects like VDI are typically something like 10-to-1 data reduction. The reason why our data reduction is so good is that we dedupe and compress at the 512 byte level, and it's a variable bit block size too. So basically, the way it works is that I/O arrives at any fiber channel or iSCSI port. We're a block storage array, and those are the two protocols we support. They then live on the NVRAM modules, which go across the top of the front of the array there. And then what's really neat is that the controllers for this array are actually in the back. And you're able to do things like, I'll get into this in a lot more detail later on in the presentation, but you are able to do things like non-disruptively upgrade controllers. That's because controllers are active on the front end, which means an I/O can arrive at any fiber channel or iSCSI port. But then they're active passive on the back end. So that's how we're able to maintain 100% performance through failure scenarios, as well as code upgrades, capacity expansions, all of that good stuff. The last thing I would mention about this slide as well is that this chassis, we've engineered this chassis in-house, and we did that with the mindset that we expect the lifespan of this chassis to be approximately 7 to 10 years. And that includes things like migrating to denser SSD drives and upgrading to more performant controllers. The other really cool thing that I think, if you haven't started to hear about it, you will, is that this chassis is pre-plumed for NVMe connectivity as well. So our customers are able to non-disruptively convert from PCIe-based SSD drives to NVMe-based drives. Again, middle of the workday with no disruption to their end users, completely transparently. Next slide, please. So getting a little bit more specific into the design that we used for this particular Cisco validated design, we basically had 64 terabytes of raw capacity. So that's 40 terabytes that was in the front of the array, like I showed you earlier. And then the expansion shelf you can see there is redundantly connected by 12 gigabyte SAS cables to the base controller. So that basically gave us 64 terabytes of raw storage. And that roughly equates to 320 terabytes of usable space when you factor in our overhead, as well as the approximate 10 to 1 data reduction that we get for VDI. We get that 10x number not through lab experiments, but all of our arrays out in the field, phone home telemetry data, things like latency, IOPS, and data reduction. Never any customer proprietary data, obviously. But what that enables us to do is we actually arrive at that 10x data reduction number based upon actual customers running production workloads in the field. The other thing I'd mention here too is that just while we're on the subject of customer data, is that our arrays use AES 256-bit encryption at rest. You cannot turn it off, and we are FIPS 140-2 certified, which enables us to sell into certain 3-letter U.S. government agencies I won't mention here. The other thing too that I would stress to pay attention to as we go through some of the results is that I think the real factor of importance for VDI testing from a storage perspective is latency. A lot of vendors make a big deal about, we can drive, 1 million 4K IOPS, but I would argue that doesn't really matter if you're driving 1 million 4K IOPS and you're seeing 10, 20, 30 milliseconds of latency, because that's going to impact your end users, unfortunately. So with us, we're able to drive hundreds of thousands of 32K IOPS, but maintain sub-millisecond latency throughout, which is very indicative of a great end user performance, and it's independently verified by Login DSI. So moving on to my last slide here for now is I just wanted to show you guys how simple this storage array is to set up. So no professional services are needed to stand up our product. It's typically brought online in under an hour. And this doesn't count, obviously, power and management cables, but I think we stood this up with this has 16 cables total. You can see it goes into the MDS switch that Mike talked about earlier. And then there's, of course, the 12 gigabyte SAS cables, but this is really it in terms of setting up the array. And then from there, it's simply a matter of powering it on, assigning IP addresses to management ports, zoning it, and you are up and running. Everything is designed to be auto-tuned so that it just really works out of the box. with that, I think I'm going to pass it back to, let's see, who is it? To Mike to talk a little bit more about the details of this solution.
Okay, thanks, Kyle. That's really, really good. And the Pure Storage Array has got some really super unique features. And I think one of the things you really didn't brag about, but I think is really awesome, is that with your maintenance agreement on your flash array, you're entitled to upgrades. It's part of, there's no big, okay, now I need a controller upgrade. You know, you're going to have to lay out a huge amount of money to get that upgraded. I think that's correct, right, Kyle?
Yeah, and thanks for touching on that, Mike. You're right. I kind of forgot about that in trying to get through this. But yeah, the way our product works is that you have an initial CapEx spend to buy the product. And then after that, it's always flat and fair maintenance renewals. So long as our customers are up to date on maintenance, we basically give them our latest and greatest equivalent controllers for free every 3 years. And that's part of the magic of that chassis design as well. Although all of our generational upgrades are completely non-disruptive as well, but to upgrade to our latest generation controllers is simply a matter of sliding out the secondary controller, replacing it with the new upgraded controller, waiting for it to come online. Like UCS, we are totally stateless as well. So the new controller will basically automatically configure itself, and then you repeat with the primary controller to upgrade the old primary controller to the new one. It non-disruptively automatically fails over with no performance impact, and then you are upgraded to the latest and greatest. But thank you for touching on that, Mike.
Yeah, absolutely. I think it's a really, really good investment protection feature of the Pure Storage flash arrays. So we'll talk a little bit about here about the solution software and firmware. Our UCS firmware that runs on those fabric interconnects, we use the version shown here. The Purity Code version, again, that's what was running on the Pure Storage Flash Array M50. We used ESX60 Update 1. We talked about the server platform for XenApp and the desktop operating system software. We used Office 2016 for XenApp and XenDesktop. And we use XenApp 7.9 PVS provisioned RDS VMs, and our XenApp environment was virtualized. It's not bare metal. I know some people still do that, but you know, we converted over to virtualized everything as we started out with UCS. For XenDesktop, we had both MCS and PVS provisioned desktops, and we use Login BSI version 4.1.5 to benchmark our results. And if you're not familiar with Login BSI, you can simply go to loginbsi.com, and there's a good overview, lots of good information. It's basically the benchmarking tool industry standard for desktop virtualization. So those are the things we use. And then, of course, the hardware inventory, we had 4 5108 blade chassis that I showed you before. We use 2 infrastructure hosts dedicated for running services like storefronts, PVS, SQL servers, the desktop brokers, Active Directory servers, and things like that. So those services were all run on 2 dedicated blades in the system. Our workload hosts, we had 28 blades that held up to 5,000 seat study, and they were split between RDS, XenApp, and XenDesktop service, and we'll show you more about that. Again, the 1340 converged network adapters were in the blades, 2 fabric interconnects, 2 Nexus 9372s, and a pair of 9148s, and that all gives you the no single point of failure on the hardware side. We're completely redundant through the whole system with server N+1 fault tolerance at the cluster level, and then at the switching level, we're fully redundant there. And as Kyle just talked to you about, the Flash Array M50 has built in with 2 controllers, so we're fully fault tolerant there. So I think let's skip the cabling because Kyle kind of went up to that. The cabling in the architecture was simply 4 10 gigabit uplink ports from every chassis on each side, so a total of 8, 4 to each fabric interconnect. So there's 40 gigs of uplink from the chassis to the fabric interconnects, and then we had, I think we had 4, right, Kyle, 16 gig connections from the Flash Array M50 to the MDF switches?
That's correct. Actually, the M50 array, we had 4 16 gig FC connections per controller for a grand total of 8. You could certainly do it with 4, but just for the added throughput afforded by the extra 64 gigs of bandwidth, we generally recommend that, but we just definitely have customers who do it with less as well.
Right. And so the logical architecture is really similar to most Citrix deployments. Starting on the left side, we use our session launchers. That's the login VSI environment to launch sessions against the virtualized desktops and server sessions. And we use, obviously, Citrix HDX protocol for that communication. We have our launcher environment is totally separate from the test bed because it really doesn't play into, there's no sense of putting it into the test environment. It's a completely external workload, and it would be similar if you had your employees or your customers that were coming into the Citrix environment to be coming from laptops or desktops or things like that over the HDX protocol into the data center with the XenDesktops and things like that, and then the infrastructure components that I mentioned to you, they're on the right. And PBS servers, I don't think I mentioned, but in this particular study for 5,000 seats, we used 3 PBS servers to hold up that load and make sure that we could do N+1 on the PBS servers. So that's the logical architecture. And at this point, I'm going to turn it over to Sagnik so he can talk a little bit about the XenDesktop and XenApp.
Hey, thank you, Mike. You can transition to the next slide. So I'll quickly try and cover the XenApp and XenDesktop in context to the testing that was conducted by Cisco and Pure, published under the Cisco validated design. So for those who aren't updated with our service options, Citrix introduced last year 2 service options. So what we did was profiling our customer base, and there is one profile of companies who are highly invested into rapid innovation, developing new use cases and faster enhancements. So for them, it's the current release, which we release every quarter. And another is a long-term service release of the LTSR, which we'll also talk about more. Next slide, please. So like I said, so for the current release, typically this customers look at accessing to the latest security, productivity, and collaboration features. They are very much into developing new use cases, looking for fast access to new features, addressing even more use cases, and of course the shorter turnaround time for implementing such enhancement requests. So for them, the right fit is using the current release, which we release every quarter. So the Q4 we released 7.12, Q3 it was 7.11, and Q2 it was 7.9. So these are the rapid stuff that we keep doing. And apart from that, Mike, if you could transition to the next slide. We have the long-term service release, which is typically addresses the large organizations who have typically big deployment size. So what they're looking for is predictable maintenance. So we provide them with 5-year maintenance support and 5 years of extended support. We have extended life cycle for scheduled cumulative updates with fixes that we release more like every quarter or so, but definitely no features, only fixes that goes into the build. And also with this comes reduced IT costs, because it simplifies the overall ongoing management and maintenance that significantly brings down the costs of the IT migration down. So I'll touch upon, there are a lot of features that we can cover on 7.9 release, but what I would like to focus on will be the Windows 10. Mike, you can transfer to the next slide also. For one, Windows 10 has set a record to have increased user share in 1 month during its first August release in 2015 for any operating system, which itself is an heavy indicator for future adoption. And Windows 10 has been making a headway very quickly on that regard. The next is the Microsoft is aiming for 1 billion devices running Windows 10 within 2 to 3 years, and to help achieve that goal, they're investing boosting a lot. So in fact, it had been the fastest deployment of Windows on a launch day itself, which amounted to about 14 million devices were running on Windows 10 within 24 hours of its release. So that says a lot. And third but not the least is that it's free for consumers, so little barrier for adoption. One concern that comes up often when is the high app compatibility. So from XP to 7, there were a number of issues when that customers faced with full of app compatibility challenges, plus most enterprises were going from the 32-bit to 64-bit at that point of time. But now that these enterprises are now on Windows 7 64-bit more or less, there is a very little friction that we see. Next slide, please. So when we start to look at adopting a new desktop operating system, there are typically three facets that we must examine. So one is that many organizations have implemented or adopted a BYOD policy that enables employees to bring in personal devices. And with the rush of Windows 10 devices hitting the shelves, the easiest way to embrace these new Windows 10 devices is to simply enable employees to download the latest Citrix receiver 4.3 or higher that supports Windows 10. And assuming that your corporate applications and desktops are hosted on XenApp and XenDesktop, Citrix Receiver makes it easy to embrace these new Windows 10 devices in the enterprise. The latest received version is 4.6. The next aspect of the migration process is, of course, moving our business applications from an older operating system to a newer operating system. While we know that the app compatibility between 8.1 and 8.10 is fairly transparent, there is still no guarantee. And what if you are still on XP? Well, you aren't alone. But the point here is that we still need to test application compatibility with Windows 10, and again here Citrix is here to help. With App DNA, we can assess your application compatibility with Windows 10 and provide guidance on how to remediate app compatibility conflicts to help streamline the migration process. And eventually it's likely that your organization will in some way standardize on Windows 10 corporate desktop image. So what better way to push out a standard Windows 10 image to all of your employees than managing one master golden image in the data center and rapidly delivering that Windows 10 image to any user on any device, all from the comfort of a data center. And now with the current release and the LTSR, both in XenDesktop and XenApp, you can do just that. Next slide, please. So we'll talk about more about the Windows 10. I'll just try to touch about, Mike, you can move to the next slide. Is the 7 new additions that we have done here. We have from the MCS perspective, machine creation, we have added RAM-based caching where you can leverage high-performance RAM for read-write activities, which dramatically reduces the amount of storage required for VDI or a virtual server. From provisioning services, this has been enhanced to add the ability to update the locally attached boot device manager, the BDM partition. In addition to being able to easily update the boot device manager or the BDM, BDM now supports with modern firmware, including the UEFI. Apart from that, we also have enhancements in remote PC access, and XenServer also supports Windows 10. So these are more or less the key features that we would like to point out when you're looking at rapidly deploying Windows 10 desktops. I will now hand it over back to Mike to take it forward.
Thanks, Sagnik. That's really good information about this robust support for Windows 10. Cisco transitioned from Windows 7 to Windows 10 for all our platform testing last July, so we're kind of in sync with Citrix in that regard in terms of seeing the rapid deployment and the response of the end user community to Windows 10. It's been really a much faster uptick than it was certainly from XP to Windows 7 and then Windows 8, which most people skipped, and now Windows 10 has got a lot of traction. So real quick, this is a hardware configuration. I'm not going to go through it all. It's here for your reference. It's in our CVD as well. You can see the XenApp servers, and these are actually the hardware B200M4 server configurations. But one thing that I do want to point out is the green line, and that is the maximum recommended workload. This, again, going back to an earlier slide, this is the maximum number of RDS sessions that a single blade can hold up without compromising end user experience. So we use the Login VSI end user experience charts along with our hardware operating system charts to show that that is the top of where we want to be, and that helps us develop our N+1 server count for the RDS cluster. Again, over on the right side, that same green line, 190 VDI users, that's 190 Windows 10 with Office 2016 users on a single B200M4 blade without compromising end user experience, and that's again for N+1. So here's the tested configurations. I kind of talked about this before, but here's what we looked at. So on the left side of the slide, we look at single server testing, and that's again where we determine that maximum recommended workload. And you can see, you know, the 190 number was true for both pooled and persistent desktops, and then the 280 RDS sessions per blade for the XenApp. And then we go to cluster testing. So we say, okay, what does 1200 pooled VDI or 1200 persistent VDI look like? Let's do 3 runs and make sure that we can get consistent, reproducible results, and then we have good confidence that we can run that load. And as a final measure in the cluster, we fail 1 blade out of the cluster and make sure that the full workload, 1200 VDIs or 2600 RDS sessions, will still run with essentially the same Login VSI performance. Really not a real significant change at all in baseline response or index average. And then the scale tests, we put it all together. So here's a little bit about Login VSI. I'm not going to give you I'm not going to go through this either. It's a description of how the workload runs if you're not familiar. Download the deck and read about it. Go to the site and find out, but it's basically, again, we run it in benchmark mode, which means we can't change anything to make our system look better than somebody else's system. It's really the de facto benchmark test for VDI. And here's the results. If you haven't seen it before, the top right corner is a Login VSI performance chart. The key metrics is on the left side here. So what we have is for XenApp, hosted server, single server testing, we use, again, the Windows 2012 servers, virtual servers, that is, running XenApp, 6 virtual CPUs and 24 gigs of RAM allocated to each server VM, and we used 8 of the XenApp servers per B200M4 blade to get 280 RDS users. Our baseline, which is in red, it's kind of maybe a little hard to read there, is 630 milliseconds. So what that tells you is that at the beginning of the test, how fast the users get their responses. It's sub 1 second. And at the full maximum workload, we're at about 1.2 seconds. And if you look at competitive documents out there, you'll see that the Citrix Cisco Pure combination of XenApp is unbeatable by anybody. And in the bottom right quadrant, this is for reference, this is the 2 infrastructure blades, the C1 blade 8 and the C2 blade 8. We show you where the VMs are positioned for fault tolerance. And then on the C1 blade, that was where we used the 8 virtual machines running 280 user sessions. And you can see at the bottom left corner of the screen a measure, you know, a very good, reasonable, bad. Well, our baseline performance is really deep into that very good range, so you can deploy the solution in this way and you'll get really good results. So here's the same data for non-persistent. Here again, the baseline response time, 778 milliseconds, and all the other parameters you can read for yourself. It's a Windows 10, 2 gigs of RAM, 2 vCPUs. Our recommended max is 190 users. And again, our baseline response time was in the very good response range, top of the range. So excellent performance there, even at max load. And finally, the persistent single server testing. Same virtual desktop configuration. 2 gigs of RAM, 2 vCPUs. We had an 829 millisecond response time in this particular case, which is still in the good range. And the end user response time, as you can see across the chart, are really consistent with, again, 1.1 index average response time here, 1.1 second index average. So here's what our CPUs look like in this range, and this is what I was telling you earlier. I won't spend a lot of time on it. On the very left side of the chart is the boot phase, and then we cool down. Windows 10 does some interesting things on cool down. The top chart is the Windows 10 desktop. The bottom chart is the XenApp server, a virtual machine, boot and test results. And you can see that we let it cool down because Windows does some tuning on its own as it settles down, and we want to make sure that all that tuning is done. It's about a 20-minute wait time there that we wait for it, and then we start our login VSI test. You can see the hill climb there. That's the number of users ramping up all the way to 190 at the peak, and we're just touching a little over 90% CPU utilization, which you wouldn't want to run this hard normally, but in a failure situation, the servers can run like this for very extended periods of time with no, detrimental effects on user experience or performance. On the bottom chart, you can see we're in the mid-80s. They're up to maybe 90%. So again, we're in good shape. So the hardware can hold it up. Let's take a look at cluster testing. So this is the RDS cluster, 2,600 users. Again, these are B200 M4 blades running a XenApp with 6 VCUs and 24 gigs of RAM. In this particular case, we have 10 servers running 8 VMs each, so a total of 80 VMs running and holding up 2,600 user sessions with a 604 millisecond, that's 0.6 second average response time, and we're at 1.3 seconds roughly index average. So it's super, super good performance compared to anything out there in the market. If you look at the RDS cluster there, we have 2 chassis that are holding up RDS, and we have 5 blades in each chassis, and then we reference the 2 infrastructure blades down there. So we have the load balanced across chassis. So we have some chassis fault tolerance, and we also have cluster blade fault tolerance. So we ran the whole load with 9 blades, and it ran with a plus or minus 5% on the baseline response time, which we believe is acceptable. It's way better than acceptable. It's superior. Here's the cluster testing for non-persistent. Same data that you're seeing on the screen here. Key thing is, in this particular case, we were running 1,200 desktops. We used 8 blades to do that, giving N+1 server fault tolerance, a baseline of 759 milliseconds, again, sub 1 second. And our average response time is right at 1 second. So this is really superior virtual desktop performance here. The final cluster test was a persistent cluster, and in this particular test we used 8 blades again, with 7 blades being able to hold up the entire workload. Our baseline response is 0.8 milliseconds, 0.8 seconds, 809 milliseconds. Again, really good end user response times, and in this particular case we had sub 1 second average response times, which is just screaming fast. I mean, you just can't, nobody out there is doing this. And so you can deploy this solution and get really, really excellent results. Again, now with not running in max workload, you can see the same data, the XenApp charts on the top here, and the VDI charts on the bottom, and we are showing boot up and then ramp up in steady state. You can see that at normal operating conditions, we're running about 80% on the XenApp servers, and we're running somewhere just below 80% on an average, 75% roughly average CPU utilization on the VDI servers when we're not in a stress situation. So here's the big one. Here's what the 5,000 user looks like. There were 4 chassis, as I showed you in the physical drawing. Here's how the blades were allocated. You can refer to this. I won't go through it in much detail, but you kind of get the idea of how we did it. So we had 1,200 persistent desktops, 1,200 non-persistent desktops, and actually the slide says 2,400, but there was 2,600 XenApp PVS hosted shared desktops, provisioned by PVS 7.9 or MCS 7.9 again. And we used a total of 26 blades to host the 5,000 user workload. There was no BSI max, which we never get. And the baseline for the entire test was 809 milliseconds, sub-second baseline. And here's the login BSI chart, and you can see with 5,000 users running, our index average response time is 1.1 seconds. That is just spectacular. End user response times. Your users will love you if you deploy this solution. And so some of the things that we want to show you is, it's not something that we, take lightly. So here at the top, you can see the director, the Citrix director site, showing that we had 5,000 sessions connected. Our average login time is 30 seconds. And match that up against other people, and you'll see that we're much, much faster there. The middle left slide is the PVS console, showing that we had good load balancing by the 3 PVS servers in the study. And the bottom right slide is the Citrix Studio that you're all familiar with, showing that the 3 desktop groups in the study had all their sessions connected with no disconnects and no unregistered sessions. So, this is proof of the pudding that this solution really, really works. And here's a sample XenDesktop and XenApp host CPU at full scale load. And you can refer to this. You can see that we're really well inside the envelope of the normal operating parameters for a high performance blade server. So there's no issues there. And now I'm going to turn it back over to Kyle and let him talk a little bit about the storage performance.
Sure, Mike. So thank you very much. Those are outstanding, great results. I just wanted to briefly touch on here to show this is what the Pure Storage GUI looks like. And this, similarly to the result that you showed, I just wanted to highlight the fact that we showed the various phases of the login BSI test and highlighted them from our GUI here. So you can see we start and register all 80 2012 R2 servers in about 2 minutes, let it settle down. Then you can see the orange brackets in the middle are the ramp-up phase. So that's actually ramping up 1 user at a time over that, I believe it's a 48-minute launch window. Then, of course, a simulation steady state, so we can take measurements of how everything performs when all users are active on the environment. And then it logs out. So this, again, is the 2600 RDS user XenApp testing. If you go to the next slide, I just wanted to briefly show what the 5,000 user tests looks like from Pure Storage. And so what's really great and crazy here, I think, is that not only do we boot the entire environment in about 20 minutes, which is about over 100 VMs and server VMs per minute, which you can see on the left there. We are also able to maintain sub-millisecond latency from a storage perspective throughout the entire simulation, despite pushing tons and tons and tons of write bandwidth and IOPS against this array. So whereas IOPS is a measure of concurrency, which you can see we have a lot of, latency is the true measure of performance. And as you can see, this array has the horsepower to support 5,000 users in parallel without stumbling at all. Next slide, please. So just a quick housekeeping item too. I know we have 4 minutes left before the top of the hour. I think that Mike Sagnick and I are able to stick around for an extra 5-10 minutes if there are any questions. But I did quickly want to talk about the resiliency test, which we alluded to earlier. So if we go through here, basically after we had proven that the array is able to handle users at scale, we then repeated the test. In this instance, it was with 3,600. We also did 5,000, but this example, we did 3,600 users, and in this scenario, we basically did an upgrade to the Purity operating environment, which is, the brains of our storage solution. So you can see these are front-end statistics that I pulled off of the array during this test. The drop in I/O is actually not a drop in performance. It is a drop in I/O because this controller obviously fails over and then starts seamlessly fails over within, I think, a millisecond or two. And that's how we're able to transparently do things like firmware upgrades to the array, or even generational controller upgrades or capacity expansions. We can survive 2 drive failures at once. Anyway, this is the section where we basically proved it while login VSI was actively running against this environment. Next slide, please. And then finally,
okay.
Mike, I think, yeah, this is the last little section here.
Yeah, so we want to give you some data. A lot of you may be running Windows 7, or Sagnik said some may be even running Windows XP. We don't have data. We do have data, but it's very old on Windows XP. Here's a comparison of what happens when you move from Windows 7 with, say, Office 2010 to Windows 10 with Office 2016 on the same hardware platform. You can see that there is a significant overhead for Windows 10 and Office 2016, most of which is the difference between the graphics content of the two operating systems. Generally for VDI with Windows 7, we disable everything with Arrow and all the graphics things we can, and Office 2010 wasn't heavily graphics oriented, but both Windows 10 and Office 2016 have a much higher graphics component, and surprisingly, it's about a 30% difference. 10% of it is due to Windows 10 itself, and 20% is due to Office 2016. And so here's a chart that gives you a comparison on CPU utilization. The blue line is Office 2010, and the yellow line is Office 2016, and it shows the difference in the CPU utilization of 9%, but the overall difference is higher in terms of the whole virtual desktop running with Windows 10. So if you want to learn more about our CVDs, you simply go to www.cisco.com/go/VDI CVD. With a couple of clicks of the button, you'll land right on the result on the right side, which was our XenDesktop 7.9 flash stack CVD. So with that, I know we're getting really close, and I want to make sure we have time for Q&A. So I'll turn it back over to Sagnik.
Hey, thanks, Mike. Thanks, Kyle. I will quickly run you through the questions that has been asked on the panel side. One thing that is really connected to the last thing that you just talked about, does this solution support NVIDIA Grid GPU graphics?
I could take that one, Mike. And the answer is yes, it certainly can. We did not do that as part of the testing here, but I think that introducing a solution like NVIDIA Grid would not only be great if you have some more CAD users or graphically intensive users, but I think it would also have the side benefit of offloading some of that graphical processing from the ESXi host memory and RAM to that, say, NVIDIA M10 card, and that would actually increase your amount of user density that you'd be able to have per host.
Perfect.
Yeah, just to add to that, so the B200 M4s you can put an NVIDIA M6 graphics card into. If you want higher density cards like Kyle referred to, the M6 or the M10, you could add UCS C240 rack servers that can handle those bigger PCI cards.
Got it.
Yep.
Okay. And what does a customer need to do if they want more than 5,000 seats? How do we add on to this solution?
So the idea is, this is a kind of a building block solution. So for UCS Fabric Interconnect, as an example, we can support up to 160 blade servers or rack servers in a single UCS domain. So when you think back to the architecture, the switching and Fabric Interconnect architecture, we use 26 blades here, so you can basically go out to 4 plus X times 5,000 on the Cisco UCS side before you have to make infrastructure purchases again. And Kyle, you can address the scaling and on the storage side.
Sure. Thanks, Mike. And yeah, I think that from a storage perspective, it would be a matter of purchasing a second array. And what's really neat about us too is that if you say wanted to do 6,000 users or 7,000 users, you could have your existing M50 array, as we showcased in the design, add a second, say, M20 array. So we have 4 controller lines that all fit within that same 3U chassis. And that would enable you to right-size your deployment and then basically do either capacity or performance upgrades as you continue to add users to the environment. So you're basically not stuck, spending money for a more expensive array or even UCS servers, right? So you can kind of upgrade as you need versus having to buy and provision everything up front and then grow into that. So there's a lot of flexibility there in terms of growing your environment.
Excellent. And one last question before we close. Why did you choose 5,000 desktops?
Basically, if I'll take it, and then Kyle, you can comment from Pure's perspective. From our perspective, deployments for VDI are becoming bigger and bigger. And our field sales guys, we used to do 2,000 seats. That used to be a big deployment of VDI. And over the last year, the deployment sizes have gone up to 10, 20, 30, up 1,000 virtual desktops. So we needed a bigger building block for deployment. So that's how Cisco kind of came onto that 5,000 seat scale.
And I think I would add quickly two things. The first one is I think it fits in one rack, which is nice, So I think that having everything managed within a single rack space is a nice logical way to organize your VDI environment. But to that end as well, the second point I would have is that at that large of a scale, you really do need to start thinking about fault tolerance within the environment. What if somebody walks by that rack and trips over the power cable? So I think that having a certain level of fault tolerance within your VDI design and managing it as different, for lack of a better term, fiefdoms at that scale is a really powerful and good way to organize your environment.
And just one last comment to add on, Kyle. That was good insight. One of the things we didn't talk about that I want to put out there for you guys is Citrix, Cisco, and Pure as a team, want users to know that this solution, when put together as shown from a Cisco hardware, a Pure hardware, and a Citrix software perspective, is about $400 per user. So the old price point for VDI is coming down big time. So you can deploy this many users on that Pure storage array with the Cisco infrastructure and Citrix XenDesktop and XenApp for about $400 per user.
Wow, and that's a great TCO, right? And I think we are more or less done with the questions. We will definitely get back to you guys. Whoever has some more questions, you can reach out to citrixready@citrix.com by email. Also, I see some of the folks have requested for the slides and the recording of this webinar. To answer that, yes, we will be sharing the recording with the attendees within a day or two to your registered email ID. With that said, we're about to end today's webinar. I want to take another moment and thank our speakers, Mike from Cisco and Kyle from Pure Storage, for making this fantastic presentation and sharing their great insights with us. And last but not the least, I want to thank each one of you for staying a little bit late and also attending our webinar today. I'm sure it was very helpful to you guys. And with this, the Citrix Ready Technical Webinar Series comes to an end. And we shall, by this, we conclude our broadcast. Thank you.